Welcome back, folks, to the Get a Grip on Lighting podcast. On today's show, we have Bolis Ibrahim. I'm going to read a quick bio on him before we jump into it. Bolis comes from an electrical engineering and project management background in both the electronics manufacturing and electrical contracting industries. Bolis is passionate about the rise of intelligent buildings that utilize DC, direct current, power distribution, advanced sensors, and intelligent automation to dramatically reduce energy consumption, to achieve net zero operations. He is the co-founder and CEO of Argentum Electronics Inc., a technology company that is conserving energy and emissions for any building type through intelligent modular DC direct current power systems, sensors, and building automation software. All the links to his company will be on the Get a Grip on Lighting website, but it's argentum.ai. Argentum.ai. But before we get there, Greg, we got to talk about some gripping, some locking, like get a grip on grip lock. What do they got? Grip lock.
Well, hey, so one of the first things I did when I was in lighting was I've looked at what fixtures are hung with. And a lot of times they're still hung with chain. You need to
Yeah.
free yourself of the chain. I'm telling you, the first thing I got a grip on with lighting literally was how to hang it. And with this grip lock system, it gives you the tool-free adjustability, a ton of labor savings, and it lasts a long time. I've done tens of thousands of fixtures hung with this. I've never used chain. I always use grip lock personally, and you guys should too, because it is the best system out there for hanging lights.
Especially when you're hanging flat lights, because round halides that had one point of hanging, they would center
Mm-hmm.
themselves and level themselves. But you need that ability to get that level on there and get that fixture nice and straight, and griplocksystems.com can help you do that. Go griplocksystems.com. I'm going to do it again. griplocksystems.com for Grip Lock Systems. Of course, that will be linked on the website as well. I love keeping it neat, keeping it tight. That's right. There's actually a technical name for these kinds of hanging systems, but I can't remember right now. It's like mechanic, blah blah blah. But they work amazing.
Aircraft cables, yeah, whatever. They're the
There's
best.
a name. I'm gonna
Do it.
think of it over the show. But for right now, Bolis, what do you got, brother? How are you?
Pretty good, pretty good. I was just checking out grip lock. This looks awesome, actually, because like the chains is like antiquated.
Yeah, no
Awesome,
more
awesome,
chains
right on.
allowed.
Get a big
Good.
circle, right jack chain, and then put a cross through it, because grip lock is here for us.
Right
Okay,
on, nice.
I'm going to jump right, Greg. I know you always prepare and all this sort of stuff for these interviews, and you have a list of questions, but sometimes I just like to come in hot. Like, did we make a mistake 120 years ago when we chose AC over DC? Like, let's just start right back from the beginning.
Oh wow,
Tesla versus
yeah,
Edison. Was it a mistake to go AC?
wow. That's like such a deep question, actually, because like 100, like electricity is like arguably one of the most important things, like enabling human life. Without electricity, like we'd be
It's the
back where
only
we
thing we
were.
need. Listen,
It's
when people listen, I'm going to tell you right now, you're
yeah,
absolutely right about that. And people way underestimate the impact of electricity. They
yeah.
don't see it. They barely even know how it works. Like
Take
most
it for
people,
granted.
yeah, they take it for granted. Like when they say there's no economic development in the Central African Republic, the reason why there's no economic development there is because they don't have any electricity. That's why.
Yeah,
If they had
yeah.
reliable electricity, they would have tons of economic development, and people would pay whatever the cost is to get it. I'm
Yep,
telling you. So, did we make a mistake
100%.
when we went AC instead of
So
DC?
when we went AC instead of DC, it was really because of the technology like we had available. It was a mistake, but there was no way to know that it was going to be a mistake in the future, because 120 years ago, we had we didn't have computers. We didn't have like digital systems. We didn't have LED lighting. We didn't have brushless DC motors. We didn't really have a need for direct current that alternating current couldn't serve 120 years ago. So 120 years ago, we made the decision based on how easy it was to increase the level of voltage so that we can send power further. And the easiest way
Mm-hmm.
to do that was with a transformer. And transformers, these big green boxes that are in your neighborhood, or sometimes they're on the pole, they're
Mm.
these massive devices that step up and down the voltage. The higher the voltage, the further we can send the power more efficiently. So these transformers only work with alternating current. They didn't work with direct current. So that's how Westinghouse and Tesla were able to beat out like Edison Company and General Electric in the AC versus DC, what they call the war of the currents. It was pretty significant. They call it the war of the currents. Really interesting point in time and history. But fast forward 120 years, we barely have a need for alternating current. We don't really think about this because like we have outlets like electrical AC outlets just about everywhere, and then we go like, okay, that's the power we use. But really, if we think about the utilization of power, like how we're utilizing power, it's almost entirely direct current. The computer screen you're looking at right now, your cell phone, the lighting in most buildings is LED. Those are direct current technologies. If you think about new appliances, like if you go to a Home Depot or a Best Buy or wherever you buy appliances and you look at like what Samsung and LG are doing right now, they call them inverter appliances or intelligent inverter. These are just appliances with DC motors. So there are inverter washing machines, inverter fridges, like the fridge compressor is now DC.
But not
So
stoves.
so if you have if you have a cooktop that is I believe they call them convection cooktops, not convection. Sorry, convection ovens are DC motors, but the cooktop that's I'm blanking on the name. It's basically like the
Induction?
um, induction. There you go. Induction cooktops. Those are direct current, right? They don't because the frequency. It's an alternating current cooktop, but the frequency is so high. So what they do is they convert the 60 hertz that's coming out of the wall or 50 hertz wherever you are in the world. They convert that into direct current and then back into alternating current. So all of these things would be more efficient if direct current was delivered to them like straight away, right? So like, and if you think about electric vehicles, if you think about solar panels and renewable energy, if you think about energy storage, all of this stuff is again direct current. So we
What
have
about
very
grid
little
scale
need
power?
for.
We can have grid
There you
scale
go.
power at DC? No, it's all going to be AC, correct?
So today, what we have is we have 90+% of the grid scale power. There's two types of grid scale power. There's the transmission for like really long distances, and then
Mhm.
distribution for the communities.
Mhm.
Distribution will probably be AC for like the next 50, 60 years. It's so hard to change infrastructure. But transmission is already shifting towards DC. It's cheaper to build a high voltage direct current line, what they call HVDC, over longer distances than it is an HVAC line. So new lines that are being built are almost always in the transmission scale are almost always being built as HVDC. So there are hundreds, if not thousands, of these lines across the globe today. You can actually go on Wikipedia and search high voltage direct current, and it gives you a list of all of the lines across the world. So there are actually, like, you'd be surprised how many of these lines exist and continuing to be built. So it's kind of like from the bottom up and the top down, like AC is being squished in the middle. So from the generation transmission side, it's being direct current, and from the consumption, like us, we're consuming more direct current. With
Everything we
like the
use is a DC device. Almost everything you use.
almost everything,
Like people
almost
don't
everything.
realize that, and we're constantly
Yeah,
we're converting electricity all over the place. The number
yeah,
one problem that happens with a solar power panel system is the inverter fails. That's the number
yeah,
one point of failure on
yeah,
all
yeah,
of these types of things. And even
yeah,
in appliances, the inverters are failing. Like that's a point of
yeah.
failure that we don't need if we have a DC power source.
100%. You can
Um,
even, for LED lighting, the point of failure, like most commercial LED lights
driver.
come with a 5-year warranty, it's the driver. The driver fails because it's doing this AC to DC conversion, which generates quite a bit of heat and losses. Like typically the drivers are 20% loss, so like 80% efficient is the like industry average. Unless you go like really high end, then you get into like the 90s, like 95. But these drivers fail, and it's what dictates the warranty. So a lot of times you see like a 5-year warranty, it's really the driver.
It's just an
LEDs are good
inverter.
for
The
10
driver is
years.
just an
Yeah.
inverter. Right. Not all of
Rectifier, so
them.
the opposite.
Oh,
Yeah,
the opposite, right? Yes.
of an
Okay.
inverter.
So
Yes.
if you go way back on the Get a Grip on Lighting podcast, Greg, all the way back to
Okay.
episode number 53, okay, we had the LED Tinkerer on. You remember him?
Yep, I do.
And he said, "Look, I'm going to put these batteries together, and I'm going to light this MR16 after I remove the driver." And so he's hitting it with the DC current. He's like, "You don't need any of this. We could just set a DC current value. We could set it, and we could build all of our
Yeah.
LED systems in DC. We wouldn't need any drivers." And that episode was when? That was 26th of November, 2018. The LED Tinkerer came on the
Wow.
show, and he was telling me
Cool.
all about how DC is going to be the way of the future, and so on and so
Yeah.
forth. So, okay. So your company, you're not just talking about lighting, you're talking about
Mm.
renovating the home environment to become a DC environment. Craig, like this is such a massive change. It's one of those mountains Do we even, before we go back to Bolis, do we even want to climb it, Greg? Do we even want to start thinking about DC systems? I mean, come on. In
Yeah,
retrofit?
I mean, we want to think about it, but I just want to know if it's realistic because that was 4 years ago. I haven't seen a lot of traction in your biography or your intro. It's the rise of intelligent buildings that you utilize DC. Is there a rise? Do we actually have buildings doing this?
Yeah, it's such an interesting question. So residential is going to be the last by far that you can like
Mm,
for residential to take off for like single family home dwellings. For these to take off, you'd have to be able to go into a Home Depot or like wherever you buy appliances and be able to pick up a direct current appliance. There would have to be direct current outlets, right? For residential use for this to be a thing. Right now where this is taking off is it's taking off in LED lighting systems for commercial and industrial. That's number 1. So you hear of things like power over Ethernet, right? Power over Ethernet, that's like a direct current technology or PoE lighting. Um, there's the class 2 like low voltage lighting, and then there's a new type of system that's entering the code in February. So the National Electrical Code, the NEC, the February revision that's coming up this February, is going to have a new class of power system that's specifically targeted at a higher voltage direct current lighting system that'll rival the like I think in Canada it's 347 volts
yep,
AC. In the
sure.
States it's like
480.
3 or
480.
480. Yeah, there
Yeah.
you go.
Yep.
So this type of system is a 450 volt direct current system that's touch safe. So it doesn't need mechanical protection or conduit. And so you see this
I
like
never
the
buy that.
rise. Yeah,
Watch that, Bolis. That idea that
yeah,
it doesn't need mechanical protection. Listen, the
yeah.
real reason you need mechanical protection is not so people get shocked, it's so the wires don't get damaged. Like a lot of people
Yes.
forget about that with PoE, you're just going to run
Mm,
all this cable everywhere. No. You should still be mechanically protecting those cables. I don't care what anyone says because the number
yeah.
one thing is not that someone goes in the ceiling and gets blown out of the ceiling and starts on fire and dies. Yeah, that happens from time to time. God love those people, you know what I mean? But
Yeah.
mostly it's because somebody's messing around, the plumber's up there and he smashes the BX cable, even the armored cable, and it causes a short. You need to mechanically protect wires that are in a building for infrastructure. Don't even try to. The PoE guys tried that on me, and I said, listen, you've never installed or worked in troubleshooting electrical if you say that wires don't need mechanical protection. They need mechanical protection, Bolis, not just for shock reasons, but also for the fact that we don't want to be damaging the infrastructure when we're working on the building. So don't make that case. I don't like that case because it's not good. You may be right that it may be safe to touch, but it's not safe to just have in the ceiling unprotected.
For sure. And so I come from an electrical contracting like background, and it's like a family business, electrical contracting, and like I totally get it. Like mechanical protection, there are in majority of even sometimes we'll do a job where we'll say like it doesn't have to be mechanically protected, but we'll end up doing mechanical protection for this very reason that it's like longevity. Like
Mm,
this wire, like no one has to touch this wire for the next like 20 years. Like it
mm-hmm.
has to stay there, right? And the only way to guarantee that is to make the upfront investment for mechanical protection. There are certain scenarios though where the mechanical protection it's not necessary, and by eliminating it you reduce the upfront capital cost, which increases the payback period, like reduces the payback period, increases the ROI for the customer. So there are certain scenarios where getting away with not having mechanical protection is advantageous. But you're totally right in that it's not for every scenario. It's not just like let's not put mechanical protection at all because like
Mm,
sure you're not going to get shocked, but you're going to have a whole lot of maintenance issues
yes, for
like
sure.
down the line, and like difficulty to like nail these wires down, and then of course you're increasing your lifetime cost of the system by increasing like maintenance down the road. But yeah, totally. Like I get the like whole mechanical protection thing. We don't like tell people that like it has like oh you don't put mechanical protection. We never preach it.
We
It's
heard
just like
that
an
a lot
option.
in the early days of
Yeah.
PoE, Greg. You don't need conduit, you
Yeah.
don't
Yeah.
need armored cable, and I was like, yeah, you do actually still need it. Let me ask you a couple questions before we get deeper into the lighting side of it.
Yeah.
Number one, can AC wire, so 12.2BX or 12.3BX, can it be powered with DC without changing it out?
So technically, yes. Technically, the if you look at the if the cable is properly marked, which like not all are, but if the cable is properly marked, it'll have a voltage rating for AC and a voltage rating for DC. And all cables, the majority of cables will have a DC voltage rating that's higher than the AC voltage rating, because the insulation resistance to direct current is a lot higher than it is for alternating current. So the insulator thickness, which is what determines the voltage rating, the insulator thickness for DC is a smaller or thinner requirement than AC. So most AC cables, they're safe to carry DC cables.
Mm-hmm.
What's not safe for DC is mechanical contact. So breakers, so AC breakers, those are no good for direct current. Like you wouldn't be able to use those for direct current. And if you look at a properly marked breaker or the datasheet, the DC rating will be much, much lower. Same with a wall switch, mechanical wall switch.
So well, yeah, that's fine. So as long as you're addressing at the two endpoints, so the light fixture,
Yeah.
the panel, but the infrastructure can stay the same. Or what about wire nuts? Can DC travel through wire nut connections?
Yeah, for sure. So like this is all technically feasible, and what's happening now is the code, the NEC is starting, and the National Fire Protection Association, they're starting to like look at this stuff and say like, okay, people are doing it. Like there are companies out there that are doing it and using the field evaluation or field inspection
Yes.
approach instead of the
Yes.
UL approach.
Sure.
And what's in the code. So they're starting to adopt it in the code. They're starting to put it in the UL. What they're doing now, unfortunately, is they're having a special cable made, what they call like a class 4 cable made. But I imagine in the future, in the next edition, it'll be like you can use the regular BX, the regular armored cable, the regular 3-conductor cable,
Romex
the Romex. You can use whatever the cable is.
You
That
just
that
have
you
to
wanna
address
use and
each end, the use end
Exactly.
and the distribution end.
Yeah. Yes.
And are you going to be reverting or whatever that word was you called? So your power comes in AC still, right?
Yeah.
Are you
Power
gonna have
comes into the
Are you going to
building.
have losses at that point where you're reverting? What do you call?
So
What was the
here's-
word you said?
Rectifying.
Rectifying. Yeah.
Yeah. So
Who
when
picked
you
that
when you
one?
rectify,
You're fixing it, eh? You're rectifying it. Is that what you call this?
you're rectifying it. Yes, yes, yes. Well, like rectifying, like inverting is taking DC and putting it into AC. Rectifying is taking AC and making it DC. So they call those rectifiers or rectification, but it's just I guess coincidence that rectify means to fix or correct. So the rectifier, when in a regular LED fixture where you have many LED fixtures and you have the rectifiers on a smaller scale and you have so many of them, the economics don't really work to make that a high efficiency. But if you have one giant rectifier and only one for every, let's call it every floor of the building, so every lighting panel will have one giant rectifier, there the economics work that you can make it a 99% efficiency. And very low heat, very high efficiency, very low losses, because you only have one of them and space is not really a constraint. Whereas on the fixture, you have so many and space is a constraint. So you have like two constraints working against you: cost and physical footprint. So you sacrifice efficiency.
So the real benefit from a lighting standpoint is that it's going to last longer and save energy if you go with DC.
Yeah. So there's, for like power consumption for sure is a big benefit, especially for new build. In the retrofit scenario, it makes sense when you're doing like an LED retrofit, you're going to have longer lifespans. So instead of your driver being the point of failure, your point of failure is the LED. And LEDs don't fail by like shutting off or flickering. That's a driver failure. The way LEDs fail is they get less and less bright over time, and that typically will start at the 9-year mark of continuous use. So LEDs really can last. If you have a properly like made LED, like Samsung LEDs, those are rated for over 100,000 hours. It's the LED, but the drivers typically fail. And like a lot of times when the driver fails, like you'll change the driver once. Sometimes you won't even change the driver because they're like, for example, like LED bulbs. Those are integrated driver. You're not going to change the driver. You're going to throw out the bulb and put a new bulb in. So the LED doesn't get its full life. You get the life of the driver. So yeah, another benefit is the maintenance, reduced maintenance cost, because the lifespan of the LEDs is increasing.
And from an energy saving standpoint, yeah, how's that going to work? How much more? Let's just take a real world example, and it's a office 2x4 fixture that currently uses 30 watts of LED, and it lasts 50,000 hours. What are you going to do now?
It really depends where you bought that fixture and who made the driver. So if the driver is some no name, made in the same factory that the LED was made in, it wasn't like made in a specialized power supply factory, those can get pretty bad. There are two sources of loss there. There's the conversion loss, which is like all the steps of energy conversion. That's typically about like 20% loss. And then you have power factor losses. So if it's not actively correcting for power factor, you're going to lose some more energy there. The worst case scenario is like this recessed downlight from Amazon, right? This guy is 50% efficient. So it's rated at 10 watts, but really only 5 watts gets used for lighting. The other 5 watts gets like burned away as heat. And so when you think like you think 5 watts, that's nothing. But if you think like of a whole country or a whole world of recessed downlights that are all wasting 5 watts, that's pretty ridiculous. For an office light, like a 30-watt office light, you're gonna probably, like, typically ones sold here in North America. Um, Unfortunately, there's no real uh, regulation on things under, I believe, 80 watts for efficiency. So it's like a range, but typically what I've seen is they're 80% efficient, 85%. So you're going to recover about 10% of your 10 to 25, depending on where you bought the fixture. You're gonna recover like 10 to 25% in your energy bill every month. So that's for lighting. That's what you're gonna see on lighting. And then if you pair that up with like intelligent like automation, like really simply, it's just two of them. Energy, like daylight harvesting. So dimming the lights when the sun's out, that's pretty significant. And occupancy. So two dead simple automations paired with direct current power, you could see like we've seen savings when we always, for every one of our customers, we tell them send us a sample of the fixture. We'll run the numbers on these fixtures. We've seen like in some cases 50%. Like you'll have half the lighting bill. And so then it's a matter of like, what is the ROI? What is the payback period for this? And that's how people make their financial decision.
And if you're going to do DC lighting in this example, and you want to occupy or put controls on it, you need the sensor to be on the fixture, or can you mount it separately like you do right now with AC power?
Yeah, so the way everyone does it differently. Like I'm a big fan of like Lutron systems, like the way, so like our system is very similar to like the way a Lutron system works, whereas the sensors are all wireless. The reason for this is because we're at a point in time where batteries, like sensors, they last 10 years on a single battery. And so if you look at all of Lutron sensors, it's all 10-year battery life. Like Apple, like the AirTag, that's a 10-year battery. They don't even let you change the battery on some of these devices and some of these sensors. So if we can get 10 years out of a sensor that's wireless, it makes way more sense to put it wireless because we can put more of them distributed in locations where it's easy to install and easy to change the location of that sensor. And then they're paired to the fixture via software, like what's called a digital twin or a digital representation of the lighting system.
So you think all lighting is eventually going to go DC?
Oh yeah, 100%. Because it's like direct current drivers are cheaper to build than AC drivers. So DC to DC drivers are much cheaper than AC to DC drivers. Like the economics makes sense. And then you have LED fixtures that last 10 plus years.
But the only reason you would
Um,
need the driver is if you wanted to control it, dim it, or tune it, right? In that case, you could just
no,
run
you
it
need to,
right. You don't need a driver
yeah.
if you just want. You can just run an LED system directly off a DC current, can't you not?
Yeah, yeah. So you would need, well, I say driver, but really what it is, it's a regulator, a voltage regulator. So you need a voltage regulator regardless. Some of these drivers get fancy. So like our driver, this one is a wirelessly controlled driver that will allow us to dim the lights. It'll allow us to change, like do constant current or constant voltage. Allow us to do like color temperature, like tuning, or change the color if it's an RGB LED. It allows us to do like a whole bunch of things. But at the end of the day, all these drivers, no matter how fancy, they're regulating the voltage to the LEDs so that
So
the LED
the
gets the right
voltage is
voltage.
still applicable. So what would be the
Yeah.
voltage running through a house? 12 volt, 120 volt. What would it be? Or through a
So
commercial building?
today, if it was
Commercial.
if it was a commercial building, the ideal, in my opinion, the ideal is you have a mix of two types of DC power systems. One is a class four. Class four is new. Probably like no one knows about this yet. This is like all brand new stuff. Class four, which is a 450 volt direct current distribution, that's paired with a class two low voltage, which is up to 60 volts. So similar to PoE. I'm not, to be honest, I'm not like PoE is good. I just think it's not good for lighting. I think it's too like overly complex for lighting. I think that like just sending straight DC power down two conductors is like best for lighting. You don't need a whole Ethernet connection for lighting.
Mm.
Uh, a PoE is good for like security cam where you have high data bandwidth, like Wi-Fi routers, security cameras. But I think for lights, it doesn't like it's not necessary. But I like Everyone
See,
has like a
I
different
thought we
take
were
on this.
going back to the light bulb with this DC thing, Greg. Remember when we talked to Gabe Arnold at PNNL, I don't know, 2 years ago? We called him the lighting prophet.
Mhm.
Because in a way, it's almost like there's something to this which simplifies LED lighting, because not
Yeah.
everybody's going to want tunability. Not everyone's going to want, they're going to just want their lights on and off, and then you have a light bulb that just runs off DC power, and that's it, no driver. That's in the
Yeah.
cards, is it not?
Yes, so for this to be true, one of two things needs to happen. And this is like I would say like one of the holy grails is like it's like you're going like you said, you're going back to like Edison's light bulb,
Hmm.
right? Where it's like just this like really simple
Except it's
no
4 watts
drive.
instead of 100 watts or something like that, right?
Exactly.
Yeah.
Yes. And so for that to happen, either we need to standardize the voltage of the because every LED manufacturer has a different voltage of like what their
Yes.
LED panel runs off of. Either that or I think what's more likely is the power system, think of like the electrical panel, is going to be intelligent enough to understand what is the voltage
Distribute the yeah, yeah.
exactly, the correct
Or
voltage.
the fixture, the light bulb will ask for the power it wants in some way.
Exactly. Yeah.
Yeah.
Yes.
And in a sense, that's what AC light bulbs do.
Yeah.
That's what the filament does, is it
Yeah.
asks for a 60 watts of power
Yeah.
through resistance, rather than
Yes.
by asking a question, but only through resistance. I'm sure the same thing could be discovered with DC, Greg Eric.
Yes.
Um, the
Yeah.
question is, this sounds like another one of these, Greggy. We're into another one of these knowledge worker environments where
Mm.
the technical skills to do this do not exist as a trade. They are some corporations may know how to do this, but there's
Mm.
no, the International Brotherhood of Electrical Workers has no idea about this or whatever it is. It's like the lighting controls and this DC thing. These two things are going to come up together, and we're starting actually a new podcast called the Lighting Controls Podcast. But to
Cool.
me, the DC play is a lighting controls play. Greg Eric, your thoughts? You take it
That's
from
what
there.
I've understood and felt, whenever I've had these discussions, is that that's why you would do it. But hearing about the energy savings and the longer life, that's a whole new story there too. But what is it exactly that you guys are doing? I'm on your website, kind of hearing you out, but
Mm.
what are you guys doing? Your company?
Us so specifically like our company, we make three categories of product. We build direct current power distribution systems, class 4 and class 2. And so these we use them for just about anything like lighting, HVAC in some cases, or
They're
anywhere that's
basically
power
breaker panels, right? You make breaker panels.
solid state breaker panels. So
Okay.
not mechanical, they're solid state breaker panels essentially. And as well as the what's so in a traditional electrical system, you have a panel and an outlet. In the type of system we build, we can think of it like transmitters and receivers. So there's the transmitter, which is like the panel, and the receiver, which is like the outlet, and both of these things are intelligent and they communicate with each other for safety. On the That's the direct current power distribution side. We also build wireless sensor networks, so for like automation, like HVAC automation, lighting automation. And then the final thing we build is software, digital twin software, or like apps you could think of. Essentially,
So you
just
guys,
digital representations. Yeah.
yeah. So you have that, and then okay, now somebody puts that in, and then what do they need to do if they want to make their lighting DC? They need to change all the light fixtures, right?
So there are different scenarios. If it's a new build, most LED manufacturers will sell you the fixture driverless. If like a lot of them will, some of them won't. Some of them will say like we only have a UL certification for like the driver in the fixture. But a lot of them will sell you the fixture driverless, and that's a cheaper fixture. For a retrofit project, the drivers can be removed, and then they can be replaced with the DC drivers. Like for a lot of these like DC drivers exist on the market, um, and then we try to like leave it as open as possible and as easy as possible for the customer to like install it the way they want, like be able to modify it the way they want. We just provide them with the hardware and if they'd like the software.
Where are you located?
We are headquartered in Toronto, Canada. That's where we're located. But we
Okay.
do stuff like across Canada. We've done some stuff in the States. This is like still an emerging market, as you might imagine. This whole like direct current thing.
Mhm.
So like It's a lot of like frontier tech and like stuff. A lot of the technology is like enabling the safe distribution of the
You're
current.
making a huge mistake. First of all, you should have come in studio. Get a Grip Studios is right here in the wonderful city of Toronto, Ontario, Canada, of course.
No
You
way,
could have been sitting
actually.
right here. Yeah, yeah, for sure.
Oh,
Victoria Park and Steeles.
no way. That's where our office is at. Like, our office is very close to Steeles and Woodbine, and I
Oh,
live very
you're
close to
5 minutes
Victoria Park
away
and
from the
Steeles.
studio. Steeles
I
and
also
Woodbine.
live 5 minutes away from the studio. I next time I'll come in.
Okay, but
I'm coming right now.
you're making an even bigger mistake.
Oh,
Okay, and I'm going to tell you what it is, and Greg's going to go,
okay.
oh,
Ugh.
DC lighting is about sustainability. That's what it's about.
Mm. Hmm.
Okay, so when people are talking about sustainable lighting, sustainable this, sustainable that, all these stupid charging blocks that are in the world, all these cables, the endless cables and the charging blocks, the equipment we're creating and building to convert everything we use from AC to DC is such a waste. It's an incredible waste of, and then you have, this is an opportunity for the world to standardize on one type of
Mm.
power that powers all of our devices. And
Yeah.
if the, and they're talking about, oh, we want to do renewable energy. Renewable energy is all DC. All you preppers out there, all you preppers that have, you're going to live forever when the nuclear bomb goes off with your solar panels and your wind. Yeah, you know what's going to fail is your damn inverters.
Yeah.
So if you're a prepper, you want a DC house to run off your DC, energy that you're creating and your DC well or whatever. That's what you need. So I think I think that the DC move is a sustainability play as well, and I think you should add that feather to your cap because almost all of the waste inherent in lighting outside of the energy
Mm.
is from the conversion from AC to DC. There's so
Yeah.
much waste, and all that translates into carbon emissions and blah 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 blah. Let the bean counters figure that out on the other side. All I know is that it's all wasted materials, wasted manufacturing processes, making fixtures heavier. There's
Yeah.
so many reasons why the DC play is the sustainability play for the lighting industry. Let me talk to you about municipal infrastructure. Okay,
Yeah, for sure.
can street lights be powered by DC?
Yes, they should be. There's no like honestly, like the municipalities to like reduce the like waste. Like those lights are on for long periods of time, and they're high powered LED lights. They should be reducing the waste there in terms of like energy consumption, but also like drivers. Like these like so, like you'll go like municipalities like they spring on like the fancy stuff, which is like the drivers last a long time. But if you go to a parking lot with like the pole lights, a lot of the times the LEDs are flickering and like out and like these should all be like DC infrastructure going to these lights so that you have driverless LEDs that then you can expect those LEDs to be running for 10 plus years.
The Okay, so the flicker of LED.
Hmm.
Okay,
Yeah.
now the lighting industry beat the flicker problem back in the late 90s with T8 LED electronic ballasts. Okay, so taking
Hmm.
the AC 60 hertz, converting it to 25,000 or 50 hertz, whatever it did, it got rid of the visible flicker, the flicker that caused problems. Now, when that was a problem, it was 100 to 70%, 100 to 70%. So it was more of a modulation than a flicker. But with LED, it's a flicker. It's 0 to 100, 0 to 100, on,
Yeah.
off, on, off. Is this a function of AC or does DC flicker as well?
DC does not flicker, so a direct current, like the reason the LED is like kind of like flickering, like once every second kind of flicker, is because the AC to DC driver, it has a capacitor inside of there, and the capacitor, if it gets too hot, it's like the capacitor is rated for 10 years. But what happens is as the inefficiency of the driver creates heat, the liquid or the what's called an electrolyte inside of the capacitor dries up faster. So it starts to, and it's a thermal runaway. As it dries up, it gets hotter and more inefficient. And it's like just thermal feedback loop, a positive feedback loop and a thermal runaway until it fails. When it fails, that driver is unable to regulate the voltage. So it's like high voltage, low voltage, high voltage, low voltage. So you get the LED like flickering on and off, on and off. And sometimes it's fast, sometimes it's slow. In a DC-DC scenario, this doesn't happen. There is no flicker, especially if you have there's no heat generated to cause this flicker. to cause this like thermal runaway, very low heat. DC drivers can be very, very efficient, like and not expensive to make an efficient DC driver.
So you're saying there's no flicker with DC LED, direct current LED?
By flicker, if you're referring to the like flicker where it's like
Something light
failing.
modulation. What's the word, Greg?
Oh, pulse width modulation.
No, that's not it. Hang on, I gotta find a get a
Are you
grip.
talking about in the dimming when you dim?
I'm talking about everything. Yeah, could it be smoother dimming?
Oh, okay,
That's
got
another
you.
one.
So it depends how you dim. So if you're dimming, it'll have the same flicker problem for dimming. It depends how you're dimming. So there's two types of dimming. There's pulse width modulation or PWM, which is essentially a flicker. Anyway, it's an intentional flicker. And then there's if you have a constant current, you're doing a current-based dimming. But then sometimes you have color shift, depending on the how
Temporal
well the
light modulation is the term.
Yes.
temporal light modulation. Interesting.
So if you were to eliminate that, then you're going to have the sustainability play. You're going to have the human-centric play. You're going to have a whole bunch of tools in your toolbox, arrows in your quiver, if you want, to fire at the lighting industry and say, hey, wake up. Look at this. Look at that. Flicker is a huge problem, and everybody's got their heads in the sand on it. So it's something that I think your end should get out some fidget spinners. Okay? You know what a fidget spinner is? And spin it under your lights while you dim it, and you'll see the flicker on a regular LED light. And if you spin it, and take a fidget spinner outside and spin it, it won't modulate. There will be no modulation to it. If you put it under an LED light, put it under an incandescent light, there's no modulation. Put it under an LED light, you'll see all the modulation. So pull out your fidget spinners and get it right.
Those LED, that's actually a good test. That's a great test. So we run this test, and that's the reason this happens is because a lot of lighting is dimmed using what's called pulse width modulation. So they send a pulse to turn the LED on and off, on and off, on and off. And they do that like thousands of times a second. And the pulse width will change to like more on or more off to change the dim or the brightness of the LED. So if the frequency of this pulse width, right, like if it happens like, if it happens within the visible range of like human, like what we can see, then we'll see the flicker. But even if it doesn't happen in the visible range, sometimes cameras will catch it, right? Like you'll see it on cameras and it looks really ugly. It's disgusting. So the trick is to get the pulse width frequency above what a camera can see, but also multiples of what the camera can see.
Yeah, but when you dim an incandescent or a halogen, there's no flicker.
No, not at all.
Okay,
because it's
so
not,
you have to do that you have to make a dimmer with your DC stuff that just dims the milliamps or whatever the amperage that is, and you got to do the same thing. You got to go back to Edison, Bolis.
Yes.
Back to Edison.
Agreed. Yeah.
Greg.
We have,
I'm shutting it down now, Bolis. You got any final thoughts for the Get a Grip on Lighting listeners?
Oh, this was phenomenal. I think final thought is like what we say in our industry is direct current will power the clean future. That's what we always say. DC will power the clean future. So it was really a pleasure to be able to discuss this and a privilege. Thanks, guys.
Yeah. Most people, like when they don't know about us and they come on, they're like, that was so much fun because we actually know what you're talking about. Greg, Eric, I want to talk a little bit here quickly about how you hang fixtures with those grip lock hangers, man. Those, what do you do with those? Those things are awesome.
It's the only way to do it. Yeah, so they come in a nice little package with 2 kits in it and different lengths. So you can get 5 foot, 10 foot, 15 foot, whatever length you need. And it's toolless adjustability. So you get it up there and you can cinch it up and down until you get it where you need it so it's level. Try doing that with chain. I've seen it done and it doesn't work.
No, you got to stretch the chain. Lean on that fixture and stretch the chain. Oh, no, now lean on the other side of the chain. Oh, shit. It's still not level. It's not straight. Oh, man. You got to go with those that aircraft cable. There's a technical term which is brand agnostic for that, but I can't recall it right now. But we love the folks at GripLock. Go to griplocksystems.com. And I forgot in the introduction to talk about the presenters of this show, folks, the National Association of Innovative Lending Distributors. All my brothers and sisters, I met you guys down in Dallas, Texas at the ArcLight Summit. Loved seeing you guys. What a great time we all had, of course. And we learned and we hung out and the roof blew off the Dallas Market Center. That's right, when Nailed rolled in. Hot! That's right. So if you want to join us, if you're a distributor, you got to go to nald.org. nail.org. That's right. Contact Erin in the Nailed office. She'll get you all set up. You want to take some educational programs? Oh, yeah, we got that too. What about advocacy? Yeah, we're kicking ass and taking names all over the industry. Everybody hates us, but we're okay with that because we're right. If you made it to the end of the show, we love you guys, even you non-nail members out there.